Welcome to the deep dive. If you're tuning in, chances are you're gearing up for a senior software engineer technical interview and you're looking to sharpen your edge.
hmm
Today, we're zeroing in on a design pattern that comes up time and again in these high stakes conversations, a real powerhouse when it comes to discussing software architecture.
Absolutely. At the senior level, it's not just about coding. It's really about demonstrating a strong understanding of design principles and, the ability to make informed architectural decisions. Design patterns are a key part of that.
Definitely.
And the one we're focusing on today can really showcase your experience.
Exactly. Getting a deep understanding of this pattern isn't just about recognizing it. It's about being able to articulate why it's valuable, the trade-offs involved, and, well, when it's the right tool for the job.
Right.
It provides a fantastic foundation for discussing maintainability, scalability, even reducing complexity in larger systems, all things interviewers at this level are keen to explore.
Consider this your targeted preparation, really. We're going to extract the core essence of this pattern, giving you the insights you need to not only identify it, but to confidently discuss its benefits and practical applications during, your interview.
Our goal is simple: to equip you with the knowledge to not just nod along when this pattern is mentioned, but to actively contribute to the discussion, demonstrating your grasp of its nuances and how it fits into broader software design. Okay, let's unpack this. We're diving deep into the template method pattern.
Okay. So at its heart, the template method pattern provides a blueprint for an algorithm. It defines the overall structure, the sequence of steps within a method in a base class. What's crucial is that it then allows subclasses to provide their own specific implementations for certain steps without altering that fundamental algorithm's structure.
Okay, to really solidify this, let's use a relatable scenario. Preparing coffee and tea. Imagine you and Knightley have separate coffee and tea classes, right? And each has a method called prepare recipe.
Yeah, and if we looked at those initial prepare recipe methods, you'd likely see a lot of overlap. Like for making coffee, you'd have actions like boil water, then brew coffee grinds, followed by pour in cup, and finally add sugar and milk.
And for tea, the prepare recipe might involve boil water, steep tea bag, pour in cup, and then add a lemon. So what immediately strikes you when you compare these two processes?
The repetition is the key thing. Both coffee and tea classes contain the exact same boil water and pour in cup methods.
Right.
The overall flow of preparing the beverage is quite similar, but the specific brewing action and the addition of condiments are different. This kind of duplicated code is exactly what we want to avoid.
And this is precisely where the template method pattern comes into play. We have this shared algorithmic structure with both common and specialized steps, leading to potential redundancy in our code.
So the solution is to introduce an abstract base class. Let's call it caffeine beverage. This class will serve as the central place to hold the common parts of the preparation algorithm.
And the real magic happens within a method in caffeine beverage called prepare recipe. This is our template method. Often this method is declared as final. Why is making it final so important in this pattern?
Well, by declaring prepare recipe as final, we prevent any subclass from overriding the fundamental structure of the algorithm. We want to guarantee that the core sequence of actions boil water, brew, pour, add condiments remains consistent across all types of caffeine beverages.
Okay.
This ensures a certain level of predictability and control.
That makes perfect sense for maintaining the integrity of the process. So inside this prepare recipe template method in our caffeine beverage class, we'd be calling other methods. Some of these would be concrete methods, meaning they're fully implemented directly within caffeine beverage and can be reused by all its subclasses. In our coffee and tea example, which steps would likely be implemented this way in the base class?
The boil water and pouring cup steps are the obvious candidates. These actions are identical whether you're making coffee or tea, so it's efficient and logical to implement them once in the caffeine beverage base class and have all its subclasses inherit and reuse that logic.
Right, the common stuff. And what about the steps that do differ between coffee and tea, the actual brewing process, and adding condiments? How does our caffeine beverage class handle those variations?
Those differing steps are declared as abstract methods within the caffeine beverage class. We might have brew and add condiments.
Yeah.
By making them abstract, we essentially create placeholders. We're saying to any concrete subclass, like tea or coffee, you must provide your own specific way of performing these actions.
Gotcha. So when we create our concrete tea class, it extends caffeine beverage and is then obligated to provide its own implementation for the brew method, like steeping the tea bag, and the add condiments method, maybe adding lemon.
Mhm.
The coffee class does the same, implementing brew with its specific grinding and brewing, and add condiments by adding sugar and milk.
Precisely. And this is where the real benefits of the template method pattern become clear. We achieve significant code reuse by putting the common logic in the base class, eliminating redundancy.
Yeah.
We also enforce a consistent algorithm structure, ensuring every caffeine beverage follows the same general prep flow. Yet, we retain flexibility for the unique aspects through those abstract methods.
That flexibility is key.
And for senior roles, interviewers want to see you think about the long-term implications. The template method shows you understand building systems that are easier to evolve because the core algorithm stays stable, but specific parts can be adapted without huge refactoring.
Now, the template method pattern has this interesting concept of hooks. What exactly are hooks in this context?
Right, hooks. Hooks are concrete methods within the abstract base class that give subclasses an option to hook into the algorithm at certain points. These methods usually do nothing by default, or maybe they provide a basic default implementation. Subclasses can then choose to override these hook methods if they need to customize the algorithm's behavior right there, but they aren't required to.
Can you maybe illustrate this with our coffee and tea prep analogy?
Sure. Let's say we want to give the customer the option of whether or not they want condiments. We could add a hook method to our caffeine beverage class. Maybe call it customer wants condiments. This method could have a default implementation that just returns true. So by default, we assume customers want condiments.
Okay, so within our prepare recipe template method, after we pour the beverage, we have a conditional step. If customer wants condiment, that way add condiments only runs if the hook returns true.
Exactly. Now imagine we have a coffee with hook subclass extending caffeine beverage with hook. This subclass could override the customer wants condiments method to actually interact with the user. It might pop up a question, would you like milk and sugar?
Yep.
And return true or false based on their response.
Ugh, that's a fantastic example. So a standard tea class, if it doesn't override customer wants condiments, just uses the default, always add lemon, maybe.
Right.
But the coffee with hook gives us that extra layer of customization. What are the key considerations when deciding whether to use an abstract method versus a hook? When is one more appropriate?
That's a good question. Abstract methods enforce implementation. If a step must be defined differently by each subclass, then abstract is the way.
Makes sense.
Hooks offer optionality. They're extension points where subclasses can customize if needed, but they don't have to. The choice often comes down to how much variability you expect. If it's a core, always different part, use abstract. If it's something with maybe a common default or only needs customization sometimes, a hook gives more flexibility without forcing subclasses to implement everything.
This idea of the base class controlling the flow and calling on subclasses only when needed, it reminds me of the Hollywood principle, don't call us, we'll call you. How does the template method pattern embody this?
Oh yeah, the connection is very strong. In the template method pattern, the abstract caffeine beverage class is in control of prepare recipe.
Right.
It dictates the sequence.
Right.
It calls upon its subclasses like tea and coffee only when it needs their specific implementations for brew and add condiments. The subclasses don't run the show. They just provide details when asked by the template method.
Okay.
This inversion of control, where the higher level component, the abstract class, manages the algorithm and invokes the lower level ones, the subclasses, is pretty much the essence of the Hollywood principle.
That makes a lot of sense. The main logic is in the base and variations plug in when needed. And how does this relate to the dependency inversion principle? That one emphasizes depending on abstractions, not concretions, right?
Yeah, they both aim for decoupling, but maybe from slightly different angles. Dependency inversion says high level shouldn't depend on low level. Both depend on abstractions. The template method is a technique that helps achieve this within an algorithm.
How so?
The high level logic, the template method in the abstract class, interacts with the specifics through abstract methods, which are abstractions. This effectively inverts the usual flow where high level might directly call concrete low level stuff. We're depending on the caffeine beverage abstraction and its steps, and tea and coffee provide how those abstract steps work.
So we're designing our system to depend on the abstract caffeine beverage and its defined abstract operations rather than tying the base class directly to, say, a specific tea brewer implementation.
Exactly.
Now, where might someone actually encounter the template method pattern in, the real world of Java development or other common frameworks?
Well, it's maybe not a textbook, purely object-oriented example because it's static, but the sort object a method in java.utilArrays is a useful illustration of the concept.
Okay.
The underlying merge sort algorithm defines the overall sorting process, the template, but it relies on the compare-to method of the objects being sorted to figure out their order.
Ah, I see.
The sorting logic itself is consistent, but the specific comparison behavior comes from the compare-to implementation in the objects themselves. That's kind of like the abstract step being filled in by concrete types.
Interesting. So merge sort provides the structure, and compare to is the customizable part dictating the order.
A more direct example in Java's collections framework is the abstract list class. Abstract list provides template methods like sublist that defines the algorithm for creating a sublist view.
Right.
But sublist relies on the abstract methods getInit to access an element and size to know how many elements there are.
Okay.
See, the framework designers knew lists would need sublist functionality, but how elements are actually stored and retrieved would vary a lot.
Yeah, like array list versus linked list.
Exactly.
Oh.
By making get in size abstract, they forced anyone creating a new list type to define those core behaviors while giving them the complex sublist logic for free.
So if I wanted to create my own myString list using an array, I'd extend abstract list. To get all the list features like sublist, I'd mainly need to implement get and size because the templates in abstract list rely on them. I might also override set to allow changes, but the basic structure for sublist comes from the abstract base using the methods I provided.
Exactly. It shows how the template method lets framework designers give a common structure for complex operations, but delegate the implementation-specific details to the concrete classes using the framework.
So the real-world applicability boils down to a few key scenarios. Having invariant parts of an algorithm in one place, factoring out common behavior to avoid duplication, and controlling subclass extensions through abstract methods and those optional hooks.
Precisely. It's about finding that sweet spot between a consistent, rigid structure and allowing the necessary variations and customizations that different implementations need.
We also touched briefly on the UML class diagram representation. Can you quickly recap the key elements one might see there?
Sure. In a typical UML diagram for this pattern, you'd see an abstract class. This class would have the template method, the core algorithm. Within that abstract class, you'd also see declarations for abstract methods, often named like primitive operation 1, primitive operation 2. These are the steps subclasses must implement.
Right.
And then you'd have one or more concrete class elements inheriting from abstract class and providing their specific implementations for those primitive operations.
Got it. And we also mentioned an example involving application and document abstract classes. How did that illustrate the template method?
Right. That example described a common application development scenario. You have an abstract application class defining a template method for opening a document, say open document. This method outlines the fixed steps. Maybe check if the app can handle the type and open document, create the specific document subclass instance, not create document, maybe do some setup a document, and finally tell the document to read its content.
Yeah.
Doc open, then doc Dory.
So open document in the application class sets the overall process. Then concrete subclasses like my application implement the application-specific parts like how to check the document type and create their specific document subclass, maybe my text document.
Exactly.
And then that my text document class implements doread to handle reading a text file specifically.
Precisely. The application framework gives the general procedure for opening documents, making sure all steps happen. But the specific apps and document types define the concrete implementations of those individual steps.
Yeah.
It's a very common pattern in frameworks.
Okay, so as we start to wrap up this deep dive into the template method pattern, what are the absolute core concepts that someone preparing for a senior tech interview should really have down?
The fundamental takeaways are: it's a behavioral pattern defining an algorithm structure in a base class, letting subclasses fill in specific steps without changing that structure.
Right.
It's great for code reuse by centralizing common logic, enforcing consistency, and offering flexibility through abstract methods required, and hooks optional. Understanding that distinction between abstract methods and hooks is pretty key too.
And being able to discuss this effectively in an interview, it really shows you grasp fundamental design principles like inheritance, controlling extensions, and how it fits into architecture. We briefly mentioned how it compares to, say, the strategy pattern, which might vary a whole algorithm via delegation, whereas template method varies steps within a fixed structure.
Knowing those nuances definitely elevates the conversation.
Understanding those comparisons can really make a difference.
Exactly. Articulating the benefits, trade-offs, and real-world uses of template methods shows critical thinking about design and building flexible, maintainable systems. That's exactly what interviewers look for in a senior engineer.
So here's a final thought for you, our listener, as you continue your prep. Think about other common algorithms or processes you see in software development. Where could you maybe apply the template method pattern to make a design more robust or maintainable?
Mm-hmm.
Consider scenarios with a defined sequence, some consistent steps, others needing specific implementations. Exploring these possibilities will definitely solidify your understanding and prepare you to discuss this valuable pattern with confidence in your interviews.